So, ladies and gentlemen, at last we are entering in the detailing of modulation and demodulation scheme. Student will be happy to listen that we are not further going to Fourier series and Fourier transform. But while going for communication engineering, like Fourier series, Fourier transform, these are the mathematical tools. One device is very much required, that is filter. We have here on the board, we have depicted two filters. On the left hand side it is low pass filter, on the right hand side it is band pass filter. What do you see? Low pass filter has a frequency range from 0 to omega 1, band pass filter has omega 1 to omega 2. In case of low pass filter, what you see that there is a replica of the positive frequency to minus omega 1, but this negative frequency comes from mathematical consideration. It has no practical or physical existence. We will see in case of later in modulation, when we will multiply the signal by cos or sine, you will see, or you also know, there is a part of negative frequency. This is the mathematical consideration. Mathematically it comes, we have nothing to do with it because it does not practically exist. So, and in case of band pass filter, it is ranging from two frequencies, omega 1 and another is omega 2. Now, from the definition, traditional definition of bandwidth, we know that the difference between the highest frequency and the lowest frequency the filter allows is known as bandwidth. Therefore, in case of low pass filter, the highest frequency it passes omega 1 and lowest frequency it passes is 0. Therefore, its bandwidth is omega 1 in this case. And in case of band pass filter, what we see, the bandwidth is omega 2 minus omega 1. Okay. Now, why we need filter in the communication? Because of the fact that whenever we are going for communication engineering, we are doing modulation or demodulation, whatever we do, there are so many undesired signals along with the desired one. Therefore, we must eliminate these undesired signals from the desired one. Therefore, we need some filtering process. How we will filter? On the basis of frequency, we will eliminate the undesired signals. For that reason, we need filter. Now, where we will use low pass filter and where we will use band pass filter. Say I required a signal which is centered around say particular frequency. Then, which filter we will use? We will use band pass filter to pass the signal near to omega or centered at omega. Therefore, any signal which have frequency 2 omega or 3 omega and so on will be automatically eliminated, as the filter is designed to pass omega signals having frequency within the bandwidth and centered at omega. Okay, therefore, if any other signal which have the frequency in the range of 2 omega or 3 omega will be automatically eliminated and we will get the desired part. When we will use the low pass filter? When we require that we need only this part of the signal. Say there is a signal here, here and here. This signal is centered around origin. We don't need, in this case, say we are considering that we don't need signal at that frequency, signal at that frequency. It requires only a small range centered at 0. Therefore, in this case, we will use low pass filter. With the concept of low pass filter, high pass filter, Fourier series, Fourier transform, communication is nothing but water-like subject. Okay, it is truly easy. How? We will see. Now, we are now going to discuss about modulation. Modulation is what? It is a technique which is used in the transmitter part of communication. Why it is required? I am talking, you are talking, everyone is talking, or everyone using some signal, message signal, that is of lower frequency. Lower frequency, lower power, we cannot transmit it to a long distance. It will be automatically attenuated. Noise will increase the original signal. Therefore, we cannot send it to a far distance. Therefore, our motto is to use another signal which has higher frequency, higher power, and which can transmit a long distance. And what we will do, we will superimpose that message signal. Yes, we will superimpose this message signal on the high frequency, high power carrier signal, and carrier will carry the message signal. That is the main scheme of modulation. And at the receiving end, we will cut down the carrier and we will get down or retrieve back the message signal. This is the main physics. So, one is high power requirement to transmit a signal. Therefore, we need high power signal, carrier signal. And another important requirement is antenna size. We know the size of an antenna depends on the or proportional to wavelength. There may be some power on the wavelength. We are not going into that. That means less will be the wavelength, less will be the antenna size. Now, as the carrier power is frequency is very high, therefore antenna size will reduce. If there was no carrier signal, only the message signal, it has very low frequency, so wavelength is very high, therefore antenna will be a big size. Another requirement is multiplexing. Say you have two signals, both with the frequency range within the range of 0 to 3 kilowatts. Means you have a signal of bandwidth, say having existence into 0 to 2 kilohertz, another from 0.2 to say 2.5 kilohertz. You want to transmit the two signal. What will be the problem? There will be interference at the receiving end. You cannot separate the two message signals. What is the way? Okay, you use some carrier. What carrier will do? Carrier will allow multiple number of signals, and it will take the signals, message signals, into another frequency ranges, which will be distinct. As a result, the two message signal or three message signal can be simultaneously passed. Okay, so this is the main physics of modulation. What is done in the modulation scheme? In the modulation scheme, what we do actually, the amplitude or frequency or phase of the carrier signal is varied, is modified, or is modulated in terms in proportion to the message signal. What we may conclude, modulation is nothing but.
Daddy?
Yes.
You.
Nice. So, what is modulation? Modulation is nothing but changing the amplitude or frequency or phase of the carrier signal in accordance with the message signal. Okay. So, if the amplitude of the message signal, if the amplitude of the carrier signal is modulated in accordance with the message signal, then we call it amplitude modulation. There are different variations. We will come one by one. Amplitude modulation with carrier, DSBSC, double sideband, single sideband, vestigial sideband, etc. There are so many classifications. We will see one by one later. And another is angle part. What is within the carrier? You see this one amplitude and another is angle. Okay. And within this angle we have two parts. One is twice pi ft, and this will not be, and another is phase. So if we write the carrier as A cos phi, here phi is the phase, it has two parts, one is frequency part and another is angle part. Okay, sorry, this is twice pi fct. So the carrier signal A cos phi has two parts, one is frequency, another is phase. Therefore, what we can tell that if we change the carrier amplitude in accordance with the message signal, it is amplitude modulation and it has several subdivision. If we change the angle, of the carrier signal in accordance with the message signal, it is angle modulation. If we within the angle, what we are changing, we will either change the phase or we will change the frequency. If we modify the frequency, then it will be frequency modulation. If we change the phase of the carrier signal in accordance with the message signal, MT, then we will call it as phase modulation. Okay. Now, let's consider at first the amplitude modulation. What we told? What is amplitude modulation? When the amplitude of the carrier is varied in accordance with the message signal. You see, the amplitude of the carrier signal is AC, but we have added another term. If it was AC cos omega t, but the amplitude is varied in accordance with the message signal. There is a constant K. It is called amplitude sensitivity. Okay. So this is our amplitude modulated signal. Here, some terminologies we should always keep in mind. The signal that we want to actually send is known as message signal or modulating signal or baseband signal. The signal after modulation is called as modulated signal. Therefore, here MT is the message signal or baseband signal or modulating signal, and CT is the carrier signal, ST is the modulated signal. Here, one thing students should be careful that overall communication can be divided into two. One is baseband communication and another is carrier communication. In case of baseband communication, we actually send the message signal. We don't take help of the carrier. It is locally used by local telephone exchange. You are in the same telephone exchange. Therefore, using coaxial cable or optical fiber, message signal is transmitted. In case of carrier modulation, what is actually sent? The carrier signal is sent along with the message signal or modified by the message signal. Therefore, it requires carrier signal. Okay? Therefore, it is carrier modulation. So, what I was telling, don't be confused about baseband communication and baseband signal. Baseband signal, a baseband communication is the communication process where the message signal is directly sent, and baseband signal is empty message signal in the carrier modulation. So what we get in case of amplitude modulation, the modulated signal is ST AC 1 plus kmt into cos omega ct. Okay. Now, sorry, if we draw the basic waveform, say this is our message signal mt, this is our carrier signal ct, this is our modulated signal st. Okay. Now be careful about this part 1 plus KAMT. 1 plus KAMT. If 1 plus KAMT, this part, is less than, is greater than 0, that means Ka into Mt, this Ka into Mt, mod of this is less than 1, then it will always have positive value. But if Ka into Mt mod value is greater than 1, and if mod value of KMT is greater than 1, what will happen? Mod value of KMT is greater than 1. Say at any instant Ka into Mt is minus 1.2. So what will be the modulated signal? AC 1 minus 1.5 into cos omega ct. That means minus 0.5 AC cos omega ct. That means the phase of the carrier signal will change, and this is not desired, as we want to get the envelope of the signal. Okay, that means there will be phase reversible if mod of KMT is greater than 1. Okay, so this is our primary requirement in amplitude modulation. Now we'll see what is the problem that happens if mod of KMT is greater than 1. For this, students are asked to take some values at different instances and check what is happening. I have drawn two figures of modulated signal. This is ST, say this is S1T and this is S2T. What is the difference? The difference is that here we are considering that mod of KMT is less than 1. Here we are considering mod of KMT is greater than 1. You see the calculation. Here you see we are considering the amplitude of the carrier is 1. It may be different. So if we consider this is plus 1, so here we have drawn a dotted line, you can see plus 1 minus 1. Here in this part you see when we will add this empty with the carrier signal, what will happen? The amplitude of the carrier in this part, amplitude of the carrier signal will increase because it will be added by Ka, any value we will consider. You can consider 0.1, 0.2, 0.3, anything. That is, this part will increase, the amplitude of the carrier will increase here. Why? Because of the superimposing of this message signal. The positive part of the message signal will enhance accordingly. Here the amplitude of the message signal is highest, therefore here the amplitude of the modulated signal will be highest, and it will gradually and then the carrier amplitude will increase according to message signal with the highest amplitude at the initial at mt has maximum value at t equals to 0. You can easily draw it, and when the carrier is getting the negative side of the message signal, its amplitude will reduce. Okay, negative side, negative mt. So the value will be the carrier amplitude will reduce, and if you take the envelope of the amplitude, you will closely get the message signal. So by taking the envelope, you can easily get back the message signal at the receiving end. This is the advantage of amplitude modulation. No other technique is required. Just by taking the envelope of the modulated signal, you can get the message signal at the receiving end. But you see what happens if this KMT part becomes negative. Students again are asked to take values in such a way that K and MT may at any point of time, a certain point of time, is more than 1. So what will happen here? You see, from here, in this part, the amplitude of the carrier signal starts reducing due to the negative part, and when the amplitude, this KMT will be greater, will be say minus 1.2. This is initially it was say 0.9, 1 minus 0.9 at any instant. So it is 0.1 AC cos omega ct. Okay, we are considering now this figure or this waveform. What we are telling, we have the carrier signal, that is AC cos omega ct, and here KMT is say 0.9. So it is 1 minus 0.9. So what will be the amplitude of the carrier signal? 0.1 into cos omega ct. Okay, it will be 0.1. We cannot we have not made the proper scaling. It will be 0.1. That means it will be more lower value. But what happened? See very carefully. What happens when this KMT is minus 1.1 on the negative side? It can happen. Then this part will become minus 0.1 AC cos omega ct. That means the carrier signal which is going downward will now change its phase as there is negative sign. It will be minus cos omega ct. Therefore, it will change the phase, it will change the direction, there will be phase reversible, and you can easily see the envelope which was going downward following the message signal has not followed, and it has started upward journey. Therefore, it will not be so high. Okay, 0.1 minus 1. Therefore, we will not get the message signal. We will not be able to get back the message signal because of this phase reversal when KMT has crossed minus 1. Okay, so there will be phase reversible. Therefore, it is desired that mod of KMT should be less than 1 for detection of the envelope at the receiving end. Another is the frequency of the carrier signal should be very very high than the bandwidth of the message signal W. So these two conditions must satisfy in case of amplitude modulation. Thank you.